So next we're going to hear from Gideon Henderson. So Gideon is Defra's Chief Scientific Advisor and Professor of Earth Sciences at Oxford. His expertise is in climate, the ocean and the carbon cycle, and he's a Fellow of the Royal Society. He's particularly well placed to speak to us as a leading researcher in greenhouse gas removal, having led the joint report on the topic by the Royal Society and the Royal Academy of Engineering in 2018. Gideon is going to talk to us about what we mean by GGR and how it links to wider environmental aims.
Thanks very much. I've never done this before. I've never given a talk while doped up on codeine. I broke my clavicle 2 days ago, so if I make even less sense today than normal, you'll at least have a good excuse today. So I'm going to start off picking up on a comment that Cameron made about how rapidly GGRs are developing with, oh, I've got the slides here, and I hear. By giving us a little bit of a history lesson about the development of GGR and going back to Paris in 2015 and 2016. And this was the point when two very significant realizations were made internationally, which I think are worth reflecting on just 6 or 7 years ago. The first one of these was, this was the point, of course, at which we recognized internationally the need to reach net zero. We couldn't just decrease emissions, we needed to get them to zero in this century. Now for the UK, which was already a leading nation in its ambition for reducing greenhouse gas emissions, with a set legal target of getting to a level of 20% of 1990 levels by 2050, this was a bit of a call to arms. We were leading, but we had to go further if we were to meet that net zero ambition. That led fairly rapidly, following some research and reports, to the government signing into law the net zero policy in 2019. You see Chris Skidmore, the then Minister for Science, doing so in this image on the left here. So that was a very rapid process of recognition that we needed to reach net zero and government legislation to follow it in the UK. And then 2 years later, the report that we've already seen and had talked about in the previous talk in 2021 last year, the first really serious effort by any nation to lay out how it would reach that net zero target. And of course, this strategy is not complete, has some holes, but is nevertheless a big step forward in trying to work out how we reach that net zero ambition. And the bottom line is reaching net zero is bloody hard. If you look at this figure that shows where we had already gone from 1990 to 2018, you can see that there had been significant reductions. And if you were to extrapolate the dotted line between those 2 years forwards, you might believe it's plausible that we were going to reach 20% by 2050, the original target. But reaching zero by 2050 is, of course, an increase in the level of ambition, and the things that we still need to decarbonize are harder than ever before to decarbonize. We also now have a challenge of reaching effectively the same 20% reduction by 2035 as we go through Carbon Budget 6. So we've moved all the goalposts further forwards and made this challenge much more demanding. Oops. The other realization that happened at the time of Paris was really global recognition that we needed to have greenhouse gas removal. It had been research that had been talked about before, but it was at the time of the Paris Agreement that this was really formally part of the discussion, that we were going to have to do significant removal of carbon from the atmosphere, as well as cut our emissions if we were going to reach the net zero target. And as shown in this figure, this is taken from the report that was mentioned before, the Royal Society report, but there are many others that are similar to this. The recognition that really became concrete at the time of Paris and subsequently, that we needed to be removing greenhouse gases really quite soon from the atmosphere at significant scale to compensate for the emissions that we either can't reduce quickly enough or simply can't reduce at all. And we've already had mention of aviation as one that's very difficult to decarbonize. But from my Defra perspective, of course, food production, agriculture is another sector which is very difficult to fully decarbonize. So we need to see some action below the line to remove carbon as well. How can we do that greenhouse gas removal? We've had several of those schemes mentioned already today, and there are many in this room with interest in those and many others. I like this way of presenting it. So this is also from the Royal Society Royal Society report, because it tabulizes the two important things that we need to think about in any process that does greenhouse gas removal. It must both remove greenhouse gases from the atmosphere, and it then must store it somewhere. And on this figure, you see the types of removal that we might imagine through biological uptake, through natural inorganic processes, or through engineered removal. And we see the storage locations that we can think of on land, in soils and land vegetation, in dead matter, effectively, in geological storage, in the oceans, or in the built environment. And some mechanisms contain both of these processes in one. So afforestation, for instance, both removes and stores, whereas others you need to have a separate storage place to put the carbon. And we must not forget, as a critical component of all GGR, the requirement to store it as well as remove it. So I'm going to use this slide as the framing for the rest of my remarks, largely. And now I'm going to switch from the history lesson to a bit more of a lesson about what Defra is thinking about and what we need to be concerned about from an environmental point of view, given that many of the technologies that you see on a table like this for GGR are things that fall in the environmental and agricultural domain. So let's start in the top left here with afforestation and reforestation. In some ways, this is the poster child of GGR. Everyone seems to love it. It's nice to have more trees, and there's a lot of support for that. Indeed, the government's ambition and stated target is to reach 30,000 hectares of new forestry growth every year by the end of this Parliament, which would align it with the Committee for Climate Change ambition. But trees are not a panacea. They do have challenges to them. One is the primary one, perhaps, is that they need land, and land, therefore, is taken out of food production when you put trees on it. And in the current food security tension that we have, that tension becomes particularly apparent. There's also a tension in trees about how we balance the need for native woodlands or long-lived deciduous woodlands, which have significant biodiversity benefits, with forestation to grow forestry products. And some people would say it's one or the other. The answer has to be we need both of those forms of greenhouse gas removal. And we need to recognize the benefits of forestry, with perhaps building with wood a very significant form of GGR that we shouldn't overlook, with a double whammy, both by long-term storage of carbon and displacement of cement from the building system at the same time. So forestry is good, but not without its limitations, particularly that of available land surface. If we move on to the second box on here and look at soil carbon, where I think many of the technologies that people are thinking about in the room might reside, soil carbon in agricultural soil itself is beneficial. Enhanced organic carbon is good for productivity, nutrient retention, water retention, soil structure. It may also have benefits for carbon storage. There is still quite a large controversy about just how much benefit there is in the UK from that carbon storage. But there's clearly benefits of increasing soil carbon. There's also, I think, a challenge, particularly around soil carbon, about how additional the GGR is, because you might be doing those practices anyway, and particularly how permanent it is. It's very easy to reverse carbon stored in soil by subsequent action in that soil. And this is something we must keep in mind for all of our GGR technologies, is the permanence of that lock-in, which to me is at least 100 years and really should be 1,000 years to let the ocean circulate. So we need very long-term storage in our solutions. Now, in addition to those challenges, for soil carbon, as for many other technologies, we really must be able to monitor it, report it accurately, and verify it. And this remains a substantial challenge, particularly for soils. And there is a danger here and a risk, I think, that if we see significant financial resource coming into this area to incentivize soil carbon without being able to measure it and being sure of its permanence, there's a risk of continued emission being validated by soil carbon storage, which isn't permanent or sufficiently well measured. Some of the other techniques that people are thinking about here, like biochar, and like enhanced weathering also operate in soils. And I know that there's some stands outside where the demonstrators who are working in these areas are explaining more about the work they're doing to really understand that MRV component and how we might benefit from those applications. I'll come on to the third box in the left-hand column here, the bioenergy with carbon capture and storage, and we've already heard something about how this operates. It's perhaps worth recognizing, I think, because some in the public certainly do not, that biomass is already a very substantial form of energy production in the UK. And one of my favorite apps, the Grid Carbon app here, which I just took a screen grab of this morning here, shows you that this morning it was producing about 4% of our energy from biomass. On average through the year, it produces something like 12% of the UK's electricity energy. So biomass is already a significant portion of our energy supply. And by capturing that carbon and putting it underground, it could also become a really potent form of greenhouse gas removal. And this is something that BEIS and Defra are working on very actively at the moment together to come up with a strategy for biomass, being aware of the need to couple growth with burning and energy production and CCS, but also aware of the biodiversity impacts that growing miscanthus or short rotation willow or the crops that might benefit best in the UK have on the environment, and the need for really careful life cycle analysis of any such substantial biomass market. But the Committee for Climate Change, of course, is pushing us towards roughly equivalent areas of biomass as tree planting, with again significant land use ramifications. Now, the last area that I wanted to talk about before concluding is the ocean sector. And this was mentioned again in the previous talk. It's perhaps an area where I feel that the Royal Society report has already become dated. In some areas, that report in 2018 still provides quite a good summary of the technologies. But in the oceans, I think we're seeing very substantial new thinking about how we might do that removal. The alkalinity that we've already heard mention of, but also direct ocean capture of just taking the CO2 out of its dissolved form in seawater as a technology that I think has got a lot of potential. And the idea of blue carbon, organic carbon, and where that's best captured in the ocean. But these are really early on in their transition from research through the TRL levels towards being things that we would understand. And like other technologies, they're going to need careful assessment of MRV and careful assessment of the secondary impacts of pursuing those technologies. So I'll leave that table behind now and just make a few concluding remarks. I think there are many people in the room who are working on the technologies that I've shown, and indeed many others as well. GGR is going to be important in our mix, and let me summarize some of the things that I think we should keep in mind as we go through the panels for the rest of the day. First of all, that it is hard and expensive, and we cannot afford to see it as a surrogate to compensate for continued emissions in sectors that can be decarbonized. It's not an excuse not to decarbonize, so we must drive down emissions anyway. GGR is needed. I think Cameron made a very powerful case for that earlier, and it's well known and recognized from Paris onwards, and the need will increase, the market will increase similarly. Some emissions simply cannot be reduced to zero, and we're going to need these GGRs to get there. It's important to keep in mind that removed carbon must be stored somewhere. It's not enough to take it out of the atmosphere. We need to put it somewhere. Land is limited, so we can't rely on that indefinitely, and CCS is nascent and not really being operated at scale yet. So where we store is a critical thing to keep in our thinking, and it must be permanent. We've got to lock it away for very long periods. GGR must be measurable, reportable, and verifiable, and it must take into account, as we develop it and take it to market, the secondary consequences, which can be beneficial, perhaps for biodiversity, or they can be negative for air quality, or in some cases also for biodiversity. We must be aware of them and see them coming. But overall, the need for GGR research and innovation at all TRL levels is now very substantial, and it's great to be here helping in this discussion around where we're taking this as we take it towards market. Thanks very much.